Assalamualaikum and good evening to our lecturers in EET 208, our technology. I am Fauzan and I will present my project based on the topic that given before. As you can see, my project is based on the my metric ID number. As you can see, as the task is given as an electrical engineer, you are given to an electrical system that consists of a three-phase Y-connected generator, transmission loss and a load with acceptance power factor lagging according to Electricity Supply Application Handbook Version 3 ESAH. Every branch of balanced three-phase Y-connected transmission loss and the load possess a resistance and a reactance respectively. The load is supplied from a three-phase Y-connected generator at a three-line voltage with frequency as stated in Malaysian standard. The phase sequence is positive, and as engineer, I need to investigate and analyze the electrical system before as mentioned. In this experiment, the connected transmission loss and load are given based on the metric card number. As you can understood, as you can see, my ID number based on this task, and I need to evaluate the parameter on electrical system by using drop base BS7671 as or Malaysia Authority Standard. And I need to evaluate analyze the active power. I use absorbed by the loads by using 2 wattmeter method and conventional method. The simple electrical vitality relies on the presentation circuit. As you can saw on the report, to reason I do this is for the specific horsepower or kVA rating, physical size of three-phase motor or generator at the smaller in the three-phase unit, as the capacity of a three-phase generator induction motor is about 150% for the single-phase machine, comparable frame size. In this project, as following the metric number on this presentation, I initiate the value on base the 3Y connected generator. And to explain this, I use the calculation method and simulation method from MATLAB that given before, and explain to how to refer ASH as in handbook. In this, I will provide to the circuit drawing at the end of this presentation. At first, I will use the value of kVA rating as I mentioned before. For the single phase system, the power delivered by a single phase circuit is pulsating, and you can see on as indicate the two standard connection used to in three-phase work to feed system and connect single phase load, which are the Y and delta connection. In this task, I focus the three-phase Y connect generator, transmission loss and a load with acceptance power factor lagging and frequency as stated according Electricity Supply Application Handbook. From objective, as I analyze three-phase Y connected generator in electrical system and evaluate the parameters of the connect Y generator in the context of transmission and load impedance, current and voltage acceptable voltage drop, and to evaluate the active power absorbed by the load by use 2 wattmeter method and the conventional measuring method. As you can see, use the flowchart method to construct YY circuit as shown above. As you can see on my report, input line to line voltage and Y connect generator, input value, transmission loss and load at the circuit after convert from XL to L the inductor. Measure all the parameters for YY connection. At the circuit and YY connection, as shown, we got the three-phase system as being connected. The line voltage I use is 275 kV. That's given to me, and the output has been the input to the Y connected generator voltage. The value of transmission loss and load will input it into the circuit after convert to SL to L by using SL formula equal to 2 pi FL. all the parameters of the Y-Y connection in the contact transmission and load impedance, current, voltage, and absorbed power measured. As you can see the result and calculation, I use the E-line to line equal to 275 kilovolt, and transmission loss ZS and transmission load ZL. From my metric number, ZS equal to 96 plus imaginary 9 ohm, and transmission load equals to ZL 71 plus imaginary 9 ohm. As you can see in my report before, Z total equal to ZL plus ZS, that I got the value about 167 plus imaginary 18 ohm. E-line, my E-line, as you can see the formula equal to power of square root of 3 times E phase. My E phase equal to 0.577, so I'm sorry, 0.577 plus 275 kilovolt equal to 158.77 kilovolt. From E phase also, EAN from the point A and from point A equal to 157 as the angle of 0 degrees. EBN equal to 158.77 kilo, angle 120. ECN equal to 158.77 K, angle negative 120 volt. As I line equal to I phase, my current line equal to current phase is same. Current AN from voltage AN divided by ZT, I got equal to 945.2, angle negative 6.15 degree ampere. Same to IBB, I use same EBN divided by ZT equal to 945.2, angle of negative 126.15 degree. As the last one, I current C equal to voltage CN divided by Z total, I got the value of 945.2, angle 113.85 degree ampere. As a I phase load, I use the EAN equal to IAA times ZL from the Z load. As you can see, I got the 67.65 K, angle 1.07 degree volt. Same to the IBBZL, but the div and Z, and I got 67.65 K. As you can see, the 67.65 K is same the value, but the difference is in the angle provided. From 1.07 for EAN, negative 118.93 EBN, and 121.07 for ECN. And in this experiment also, we got the E drop equal to E supply negative E load, and divided by E supply times 100%. I got about the 57.4 57.39% is what it's got a lot of big drop on this based the theoretical calculation. And you can see the YY connection and my reading a voltage line also, as you can see on the table. I got the table, the current, the voltage line, the current line, and the voltage phase load, also the current. I'm sorry, it just three item only. As the 2 watt meter method, it is it just different thing with the YY connection, but as you can see, the circuit is still remain the same, and also we can see the difference in the waveform that provided in the MATLAB. As you can see, the table of conventional measuring method, from the calculation, I got the 190.3 megawatt, and the second one measured 193.7 megawatt as the P total of both conventional, calculated, and measured. As the result, in Y design, line current, phase current are the same, yet not for the line voltage and phase voltage with the YY connection. The voltage phase is 0.577 at the line voltage, as the main information estimated on the PSIM. As the PSIM is deemed as the somewhat unique of the parameter as the setting flow, voltage, and force consumed by loads, either utilizing 2 watt method or conventional measuring method. For the line voltage, it was about 275 kV as the input, as the reaction is the 283 kV and the 8 kV distinction. As you can see from the wattmeter technique, I got the 2.3 megawatt as the different value. At last, I'll conclude in why configuration is utilized to circulate power capacity to ordinary single phases found in the electrical technology. Since the protection is chosen by state voltage and the Y connection is about 0.5277, as the delta connection also equivalent to the protection level as in the same line voltage, and the protection required in Y connection about 57.39%, that can be utilized to higher voltage drop at the protection required in data design at the same line voltage, and cost protection it will decrease. At the neutral point, that unbiased wire can draw utilizing the impartial wire in any one phase. That's all for me. Thank you.